All right, another lesson of multiplying. This time it is 5.5. Use partial products to multiply multi-digit factors. So hopefully by the end you'll be able to say, I can use partial products to help me multiply multi-digit factors, meaning just two numbers we're multiplying together. Now, if you aren't feeling super confident about it by the end and you want to go back to the area model, that's okay. I at least want you to recognize like what this is. So if you saw someone do it, you'd be like, oh yeah, I can follow what you're doing. Okay? It's good to at least see different strategies to see if it's a good fit or not. So the problem we're going to look at this time, a stadium has 164 rows of seats. How many seats are in the stadium? Notice they also tell us there are 82 seats per row. So 82 seats in a row, 164 rows. That's just repeating 82 164 times. So we would use multiplying, right? So then what equation could we use? Well, we could do 164 times 82 equals the number of seats. So question mark, letter if they gave it to us, some unknown number. So how can we represent it using an area model like we did in the last lesson? Well, if I have, oh gosh, see, I'm going to forget. 164 times 82, right? Again, I make them so small. So 3 rows by 2, or 3 columns by 2 rows again, right? 164 by 82. So I'm just splitting it up again by place value, just like we did in the last lesson. So if we do it with partial products, we also decompose the numbers by place value. That is the same, or we write them in expanded form, whichever one you want to think of it as. So you can put that on your notes. We decompose them by place value. I know it's a long line, just in case. It was too short to fit on the line, so I just made it the whole next line. So if we do it that way, if we use partial products, we still think of it in expanded form. We're just doing a lot more in our mind instead of writing it down, which I think is the tricky part about partial products. Because in the area model, I'm still doing 80 times 100, but I have it in a nice little box, and I remember that I did that one. So without this, there's a lot more like, which ones did I do? I need to make sure to get every combination. Okay, so I still have 8,000, okay, because I did 100 times 80. So I'm still just combining the two factors. We're multiplying the two factors together. There we go. So now let's go through and do all of them. So I'll walk through sort of what that looks like. So if I have 80 times 100, now I'm going to do 100 times 2. You can kind of do them in whatever order. I figured I would do 100 times both of them, then the middle one times both of them, then 4 times both of them. So I could at least try and like have some sort of pattern. Because now I'm going to do 6, which is really 60 times 80. Then I'm going to do 60 times 2. Then I'm going to do 4 times 80 and 4 times 2. So it's really the exact same thing as in the area model. I'm just not drawing the boxes. I'm doing it more vertically. If this works for you, if you can keep track, go ahead. If you have trouble keeping track and you're missing some, then you're going to want to go back to the area model after this lesson, or maybe even in the end of this lesson, because again, we don't want to be missing numbers. That's 4,800. Then we have 120. Then we have 320. And then 8. So same thing where we get all the products. We're just doing it a part at a time. Hence the name partial products. Just in a different form than the area model. All right. Multiply each one by each of the other ones. So then once we have all of them, we just need to add up to get the total, which you don't need to watch me add, so I will just tell you is 13,448. Okay, just add them all up. Like we add a column of numbers together. Nothing different. So how many seats are there? There are 13,448 seats in the stadium. So we can use partial products to multiply those multi-digit numbers. Again, we're just doing sort of all the combinations. It's more like the area model, like I said, just without writing it down. We're just kind of doing the list. But it's also easy to miss them. What if I just accidentally forgot to do like 6 times 8? That would be a problem, right? Or 60 times 80? That would be a problem. Or what if I accidentally did 6 times 8 instead of 60 times 80? Again, there's some different areas where it's easy to miscalculate. So just be careful if you are going to use it. That being said, I had a 5th grader 5 years ago. He loved it and he did fine with it. So if it works for you, awesome. If you're like, I don't get it, go back to the area model. So 142 times 63. I will demonstrate this one for you. And then I'll have you try some. Notice the practice area on your page is not very big. So you'll probably want to either get more scratch paper or use a whiteboard. Oops. Sorry, I realize I'm not writing them in expanded form. I'm just writing 142 times 63. So I'm going to start by doing 100 times 60. Then I'm going to stick with my 60 and do 60 times 40 and then 60 times 2. I know, somehow, there's less of these, so then, I did this times this, this times this, this times this. So I'm going to do 3 times 100, and 3 times 40, and 3 times 2. And remember, I'm not doing 3 times 4, because this 4 here really represents 40, just like in expanded form, by place value, so keep that in mind. Now I can just multiply. Right, 1 times 6 is 6, put my zeros. 6 times 4 is 24 with 2 zeros. I have to make sure to write it in the right spot. 60 times 2 is 120. Then I have 300, 126, and I can add them together. So I get 6, 4, 5, 6, 9, and 8. So 8,946. Again, I'm just splitting them up, but I'm just doing it more in my mind. Now I'm going to have you practice. And if you feel comfortable trying partial products, great, give it a shot. If you try it on one and then you're like, nope, that's not for me, that is okay. But again, just recognizing what I'm doing. So let's look and figure out what the unknown partial products are here and then figure out the answer. I'll just have you choose the answer. All right, hopefully you got it. Not to say you couldn't have looked at the unknown partial products. I guess I had it covered up. But, so let's see. This is 300 times 70. This looks like 70 times 20, because I know 7 times 2 is 14. And then we have 70 times 5. So they kind of did what I did, where they stuck with that 70 for all those. So that means I still need to do this 3 over here. So I have 3 times 20. Ooh, I missed 3 times 300 almost. If they hadn't had that extra line, I might have missed it. So that's what I'm talking about, how it's easy to accidentally skip one of the combinations. So that would be 60, 915. So I'll add them up. I get a 5. My line's a little crooked. 5 plus 6 plus 1 is 12. 7, 8 plus 9 is 17. Let's see if I got this right. I'm not being particularly neat. 23,725. Let's check. Okay, good. Even with my messiness, it didn't come to caught me too much. Oh, that's weird. All right. Anyway, we're going to skip that one. Go ahead and either use partial products or the area model to solve 17 times 86. All right, I hope you got it. So let me move that. So I go up here, 86. I'm going to show you the partial products. If you tried the area method and you didn't get it, let me know and I can sort of try and help you figure out where you might have gone wrong. So I'm going to start with 80 times 10, then 80 times 7, then I have 6 times 10, and then 6 times 7. Notice I like to write all the combinations before I start multiplying. You don't have to. You could start multiply as you go. But I think it's kind of nice to focus on like which ones am I doing. Then I can do all my multiplying. Then I can do all my adding. 6 plus 6 is 12. Plus 4 is 16. 13, 14. So 1,462. All right. We'll try one more. We'll do a 3 by 2 this time. Go ahead and try 24 times 129. All right, hopefully you got it. I feel like I never have enough space for these on here. All right, 24 times 129. All right, I'm going to go 100 times 20. 100 times 4. I don't know what it is. Somehow going from the bottom just feels better to me. Again, you can do it in either way as long as you get all the combinations. All right, I have 20 times 20, and then 20 times 4, and then I have 9 times 20, and 9 times 4. Ooh, I think I squeezed in a little bar that time. 1 times 2 is 2, with my 3 zeros. 100 times 4 is 400. Then I have 400 again for the 20 times 20. 20 times 4 is 80. 9 times 20 is 180. And 9 times 4 is 36. Notice how knowing my facts, I can do it a lot faster. If you're using your chart, that's okay. But the more you can practice your facts, the easier it will be. I promise it'll be worth it. 4, 8, 9, 10, and 3. 3,096. All right. If you still need help, no problem. Just let us know. Good luck.